Okay, so in this video I'm going to have a look at axioms, and in particular I'm going to have a look at the first 5 axioms that you need to know. Now an axiom is basically a statement that we accept without any proof. So I'm going to have a look at the first axiom, which is axiom number 1, and it's called the 2-point axiom. The 2-point axiom. Now, this axiom states that there is exactly one line through any two given points. So if we take a point here and we'll call it A, and just draw a line through it here, we'll have another point here called B. There's only one line that will actually go through the points A and B. There isn't another line that you can draw that will go through, another straight line anyway that you can draw that will go through A and B. So that's your 2-point axiom. That's axiom number 1. Axiom number 2 is called the ruler axiom. The ruler axiom, and it basically talks about the properties of the distance between points. So if we take, again, we'll take 2 points, A and B. This is A, this is B here, and both points are on this line here. Now, firstly, what the ruler axiom says is that the distance between A and B is never negative. So the distance AB is never negative. In other words, it's greater than 0. Secondly, what we can say is that the distance between A and B is exactly the same as the distance between B and A. So in other words, if we take a ruler and put 0 here and measure as far as B, let's say it's 5 centimeters. If we put the 0 part of the ruler here and measure backwards, we'll also get 5 centimeters. So the distance from A to B is exactly the same as the distance from B to A. The third part of this ruler axiom says that if we have another point on this line here, we'll call it C, the distance between A and B will be exactly the same as the distance from A to C plus the distance from C to B. In other words, this distance here from A to B is exactly the same as what you get when you measure this distance and add it to this distance here. So that's the third part of the ruler axiom. Okay, so the fourth part then is the following. So if we take a ray, let's take this is X here, and we'll go on here. This is X, we'll go on through another point here, we'll call it Y. This is the ray XY, and this is written XY with a square bracket here next to the X, because the ray starts at X and it goes through Y. So it continues on forever in this direction. Now, if we take any distance on this ray, let's say, for example, 5 centimeters. So if we take 5 centimeters and we measure the distance 5 centimeters from X, let's say the distance XY, for example, is 5 centimeters. So this distance here is 5 centimeters. There is only one point. There is only one point on this ray XY that is 5 centimeters from X. So there isn't another point up here, for example, that's also 5 centimeters from X, or there isn't a point down here that's also 5 centimeters from X. There is only one point on the ray that's 5 centimeters from X. So that's your that's your axiom number 2 finished. Okay, so let's have a look at axiom number 3. So we'll look at axiom number 3 now, and this one is to do with angles. It's called the protractor axiom. So this is called the protractor axiom, and this is to do with angles, as I say. So let's take the number 1. the straight line, or the straight angle from here to here, in other words, will be 180 degrees. So a straight angle is 180 degrees. And you know, all the angles at a point add up to 360 degrees. So at this point here, if you take all the angles off this particular point, they'll all add up to 360 degrees in total. So a straight angle is 180 degrees, and if you go all the way around a full circle, it's 360 degrees. So that's part 1 of the protractor axiom. Part 2 then is similar to this number 4 from axiom number 2, but we're going to talk about angles now. So if you take a ray out here, and we'll call this x again, and let's say that we'll call this y again. Given any ray xy, there is exactly one angle of, let's say, we'll say 60 degrees, okay? We'll talk about the angle 60 degrees. There's exactly one angle on either side of the ray that's 60 degrees. So in other words, that's 60 degrees there, and this is also 60 degrees here. So there are two angles, one on either side of the ray, that's any particular angle, in this case 60 degrees. So that's part 2. Part 3 then of axiom number 3, that's going to talk about adding angles. So for example, if you have this angle here, and let's say we split it up into two angles, this particular angle here, this angle here, plus this angle here, so those two angles, this angle here, this little angle here, plus this angle here, so this angle here from here to here, plus this angle here from here up to here, will give us this big angle here. So if I number them, for example, this little angle here we'll call angle number 1, this angle here we'll call angle number 2, and this big angle here we'll call angle number 3. In other words, then what we're going to say is that angle 1, the measure of angle 1, plus the measure of angle 2 will give us angle 3. So you add up these two angles, these two small angles, you'll get angle 3. So that's axiom number 3. So I'm going to talk now about axiom number 4, which talks about congruent triangles. So there are 4 parts to this, so I'll just go through all of these. So we're going to talk about axiom 4 here. So this is going to be all about congruency. So we're going to talk about congruent triangles. And specifically we're going to talk about SSS, SAS, ASA, and or HS. Okay, so I'll go through these now individually. Firstly, I'm going to talk about SSS. Now, SSS stands for side, side, side. So, what we mean when we talk about congruent triangles, first of all, is that one triangle is exactly the same as another triangle in terms of the lengths of its sides and the size of its angles. So two triangles are congruent if basically you can pick one triangle up and put it exactly on top of another triangle. All the sides, all the angles are exactly the same size. So if we have two triangles and the three sides are equal in length, then both triangles are congruent. So if we have two triangles like this, and we'll call them A, B, and C, and we'll call this one D, E, and F, and let's say this is 4, 5, 6 here, 4, 5, and 6 here, and this is also 4, 5, and 6. You can see here that 5 is equal to 5, 4 is equal to 4, and 6 here is equal to 6. All three sides on both of these triangles are congruent. Therefore, what we would say here is that the triangle ABC is congruent to the triangle DEF. Okay, this is the symbol here for congruency here. So that's your first congruency here, SSS. Now we're going to talk about SAS. So SAS stands for side, angle, side. So again, if we have two triangles and we find that we have two sides that are the same and one angle, then we can say that both triangles are congruent. So if we have these two triangles here, for example, let's see, we'll just draw these here. Now let's say this is called, let's say DEF, we'll say, and this one here is called XYZ, X, Y, and Z. Now let's say we have this side here is called, this is 4 and this is 7. This is 60 degrees here, and let's say we have a 4 and we have a 7, and this is 60 degrees here. Okay, so in this particular case we can see here that we have two sides and the enclosed angle or the included angle equal to two sides here and its included angle, 60 degrees, all the same. So therefore we can say again that the triangle DEF is congruent to, so that should be three of these rather than 4, so 1, 2, 3 is congruent to the triangle XYZ. So you must have two sides and the enclosed angle or the included angle. The two sides must make up the angle itself that we're talking about. So in other words, if we were talking about this angle over here, it's not going to work. It must be this angle here, and it must be this angle here between the two sides or included in the two sides. So that's the second one, that's SAS. The third one then that I'm going to look at is ASA. So this is ASA, and you've probably guessed at this stage that ASA stands for angle, side, angle. So again, if we have two triangles, so we have two triangles like this, and we have, let's say this is 40 degrees here, this is, let's say 50 degrees, this is 7 centimeters, let's say this is 40 degrees here, this is 50 degrees here, and this is 7 centimeters here. Here we have two angles and the side between the two angles. Here we have two angles, the side between the two angles, all three measurements are the same. Therefore we have two angles and a side the same in both triangles. Therefore we can say that these two triangles are congruent. So again, if we call these A, B, C, D, E, F, again here we can say that triangle ABC is congruent to the triangle DE and F. Okay, so that's the third one. The last one then I'm going to have a look at is RHS. And this is to do with right angle triangles. So we're going to have two right angle triangles. This is a right angle here, and let's say we'll draw another one here that looks something like this. I'll draw it upside down if you like. Again, we'll call this A, B, C. We'll call this D, E, and F. Now here we have OR, which stands for right angle. So we do have a right angle here, we have a right angle here, so we have that. H stands for the hypotenuse. And remember that the hypotenuse is the longest side. The longest side of both of these triangles is this one here and this one here. It's the side opposite the right angle. So this side here is the hypotenuse and this side here is the hypotenuse. And then we need one other side. So say for example this was 10 centimeters and this is 10 centimeters, and let's say this side here is 4 centimeters and this is 4 centimeters. Now we have a right angle. We have the hypotenuse the same as the hypotenuse, and we have another side the same as another side. So here we can also say that the triangle ABC is congruent to the triangle D, E, and F. So that's really congruency. That's the RHS. So there are the four types of congruency that you'll need to know.